Bismillahirrahmanirrahim and Assalamu alaikum. This is Faryal Javed, roll number 21T07 from Telecommunication Engineering Department, UT Texila. So today we are going to solve lab manual 2 of digital signal processing, that is signal representation in MATLAB. So starting with the very first task of basic plotting a signal, that is to represent a step signal. Here we use a command of stem to represent it in discrete form. We have N0, N1 and N2. N1 and N2 are the starting and ending points, while N0 is the distance between them. Here we need to observe the effect of changing the values of N0, N1 and N2. So, changing values of N0 shift the signal towards right or either towards left. On the other hand, changing values of N1 and N2 affect the range over which the step signal is plotted. Moving towards task 2, that is to stimulate an impulse signal. Here N0 is the index where you want the impulse signal to have values, and then we have N1 and N2, that is again starting and ending points. Here we need to observe changing the delay period and starting and ending point. As we all know that impulse signal has property that its area is equals to 1 and it is infinitely tall at origin, and has amplitude that is equals to 1 at origin for a discrete case. Then we have a task 3, that is to stimulate the exponential signal. Here is the formula of exponential signal, and below there is a mathematical expression through which an exponential signal can be formed, that is a sinusoidal signal a cos theta n plus phi. Here is the formula. Here we use the values of amplitude base, that is zero point 0.5 to the power of n, and we need to observe here is changing effect of values of alpha and n, and then the changing values of amplitude, frequency and phase. Changing values of n result in faster decay of exponential signal. Similarly, changing amplitude, that is 3, amplifies signal vertically for the increase of amplitude. Similarly, changing base, that is 0.5, narrows the exponential signal. For a sinusoidal, we need to observe the change in phase, frequency, or amplitude. So, increase in amplitude stretch the signal vertically, and increase phase shift the signal towards left along with the time. Similarly, towards right too. And then we'll have the task 4, that is write a function to stimulate a unit impulse signal or a unit step signal. These are the task 4 and task 5. Here is the code, and the output is similar to the previous one. We have N0, that is location of impulse, N1 start index, N2 end index, generating the index and initializing the impulse sequences with response, and then we'll have the output like that. Again, we'll have the unit step signal. Here we just change the function of unit step, that is function step is equals to unit step and not n1 and n2, and we will change the values of n1 and n2 to represent in either in a unit step form or unit impulse form. Now the task 6 is to find x1 of n and x2 of n using the task 4 and task 5. Now this code defines unit step and impulse function to stimulate a sequence, and then calculate these values of sequences, that is x1 of n and x2 of n, using functions based on the given conditions, that is u of n minus 3 impulse n minus 1 with a range of minus 3 to 3. Then the task 7 is write a function that can be able to flip the given signal. Then the task 8 is to scale the signal, and task 9 is to shift the given signal. Shifting is basically a process that is either to shift it towards right or left by a specific amount using MATLAB. And here is the visual representation of the original signal with a shifted signal. As we can see, that is the greatest amplitude is at zero point 0.5, and now at zero point 0.5 there is the smallest amplitude. It completely shifts the signals from the point origin. And then we will have the scaling of signal. Scaling is basically used to increase the amplitude of signal. and then the shifting is again used to shift the signal either towards right or left. Here we use a function and we simply print its output, while in the previous MATLAB code we have plotted it. Then the task 10 is about write a program to stimulate a zero order hold and write a program to stimulate a first order hold. So basically, if stimulator affect the zero error hold, it will affect the input signal. The code stimulate zero order hold effect by repeated each sample of input signals. Multiple timers determined by the sampling period. This repetition hold value of each sample constant over duration of sampling period. So this is it from my side. Now, this is it from my side. Thank you so much, and we'll see you in the next video. Allah Hafiz.